Now we will discuss the problems in the second assignment. The first problem, it's a combination of resistors connected in series and parallel. You're required to find I1. So first you combine these two in parallel and you can see that it becomes 2.4 kilo ohms, and you combine these two in series, that will be 6 kilo ohms, and these two in parallel, so that becomes 2.4 kilo ohms. So this whole thing is equivalent to a single resistor of value 2.4 kilo ohms. Okay, I1 is 6 volts divided by 2.4 kilo ohms, which is 2.5 milliamps. So the answer is 2.5, which is the value of the current in milliamperes. Second question, again some combination. Now we also have a control source. First of all, this 12 volts is connected across this resistive divider. So it's very easy to see that Vx is 2 kilo ohms by 2 kilo ohms plus 4 kilo ohms times 12 volts, or equal to 4 volts. And this control source, it's equal to 5 Vx. So this is 20 volts. Now the current flowing in this is basically this 12 volts divided by the total resistance, which is 6 kilo ohms, that's 2 milliamps, and here the voltage across this 8 kilo ohm resistor, you can see it is plus 12 volts on this side, plus 20 volts on that side, so it is 8 volts in this polarity. You can apply Kirchhoff's voltage law around this loop and find that, and current going that way is 1 milliampere. Okay, 8 volts by 8 kilo ohms. So I1 equals 2 milliamps minus 1 milliamp equals 1 milliamp, or the answer is 1. Okay, in this case we have another combination of control sources, and we are required to find this voltage. Okay, now this voltage is V1, that is across this 3 kilo ohm resistors. By the way, all these problems, there are many ways to do it. The intermediate, there is a lot of variety depending on how you start off. I'm going to show you one of the ways, but you can do it in any other way. Okay, if you find that your answer is different from mine, probably you have made a mistake in some of the steps. You can go back and check them. Okay, then the current in this branch is V1 divided by 3 kilo ohms. Okay, and this value of Vx, you can see that it will be this current V1 divided by 3 kilo ohms times 2 kilo ohms. So Vx equals V1 times 2 by 3. So this current here is 0.75 millisiemens times Vx, which is 2/3 of V1, which is 1.5 millisiemens by 3 times V1. And the current in this branch is nothing but V1 divided by 3 kilo ohms, which can also be written as V1 by 3 times 1 millisiemens. 1 over 1 kilo ohm is 1 millisiemens. So the total current here, we know that is 4 milliamps, and that's equal to V1 times 1.5 millisiemens by 3 plus V1 times 1 millisiemens by 3, which is V1 times 2.5 millisiemens by 3. Okay, so V1 is 3 times 4 milliamps by 2.5 millisiemens, or 4.8 volts. Okay, so the answer is 4.8. Okay, and in this case we have yet another combination of control sources. The whole idea of behind all these problems is for you to set the variables correctly in problems involving control sources and proceed to solve them. Okay, so Vx is here, and we know that this is directly across this 4 volts. So Vx, we know what it is, it's 4 volts. Okay, so this current here, this one is 0.5 millisiemens times Vx, that is 2 milliamperes, and Ix is nothing but minus 2 milliamperes. It's basically opposite of this 2 milliamperes. So this 3Ix going upwards is minus 6 milliamperes. So I1 is minus of minus 6 milliamperes minus 2 milliamperes, which is 8 milliamperes. Okay, so the answer is 8. In this case, we want to find I1, and we have Vx here and 2 Vx there. Okay, and this is 2.5 kilo ohms. So the total voltage here we easily see this is 3 Vx, and that is equal to 12 volts, and Vx equals 4 volts. This I1, which is the same as the current flowing through the resistor. So this I1 will be equal to Vx, that is 4 volts, divided by 2.5 kilo ohms. Okay, which is 1.6 milliamperes. So the answer is 1.6. Okay. Here you have to find the equivalent resistance between A and B, which really means that you either connect a current source and find the voltage, or connect a voltage source and find the current. I'll connect a voltage source V test, and a current I test is drawn from that. You have to find the value of I test. Okay. In this we have this variable Vx, and Vx is directly across this voltage source. So Vx equals V test, and this current here, that is 3 millisiemens times Vx. So that is 3 millisiemens times V test. Okay, and we have a 500 ohm resistor there. So the current Ix, which is flowing this way, that you can see, that is V test by 500 ohm, or 2 millisiemens times V test. Okay, so Ix, this current is 3 times this, so that is 6 millisiemens times V test. So this current I test here is plus 3 millisiemens, is this current plus this current plus this current, all flowing downwards. It's 2 millisiemens times V test minus 3 millisiemens times V test plus 6 millisiemens times V test. Okay, which is basically 5 millisiemens times V test. So the looking in resistance, which is V test by I test, equals 1 by 5 millisiemens, or 0.2 kilo ohm. So the answer is 0.2. Okay, here it's the similar problem. You are required to find the inductance between A and B. What does it mean? So if you have some box, and let's say you have a voltage VL here and a current IL, and if what is inside the box is an inductance, then VL and IL are related by this. The voltage will be proportional to time derivative of the current. If that's the case, it's an inductance. And what's the inductance value? That is this L, the proportionality constant. Okay, so in this case, let me assume that the voltage between these is VL and the current here is IL. I have to find the relationship between VL and IL. So I see that, first of all, if this is IZ, the same IZ is flowing everywhere. This is also IZ, and what is flowing up here is half of it, 0.5 IZ. So you can see that IL is 0.5 IZ. Okay, then the voltage between these two is the sum of the voltage across this and the voltage across that and the voltage across that. The voltage across the 2 millihenry inductance is nothing but the current flowing through it is IZ. So this Vx equals 2 millihenry times diz by dt, and this Vy equals 4Vx, and the voltage across this is 2Vy, which is basically 8Vx. Okay, so we have 8Vx here, 4Vx there, and Vx there. So the total is 13Vx. VL is 13Vx, which is basically 26 millihenry times diz by dt. And using this relationship, we can write it as 52 millihenry times dIL by dt. VL and IL are related by this time derivative. Proportionality constant is 52 millihenries, so that's the inductance. The inductance is 52 millihenries, or the answer is 52. Okay. The very last problem is I1 is the sum of all these three currents flowing downwards. The first one is 5 milliamps, the second one is Ix, and the third one is 5 Ix, which is basically 5 milliamps plus 6 Ix. Now this Ix is the current through a capacitor, so Ix is C time derivative of the capacitor voltage, which is 2 microfarad times dV1 by dt. You have to find this time derivative of V1 at t equals 4 milliseconds here. So it's a straight line segment. You can see that on this segment it's falling by 3 volts over a period of 3 microseconds. Over a period of 3 milliseconds. Okay. So this is 2 microfarad times dV1 minus 3 volts divided by 3 milliseconds. Okay, this is minus 2 milliamperes. Okay, so the answer is minus 2 milliamperes, or minus 2 for the numerical value. Okay.